based
So nothing to do with the ball.
yeah, yeah, it's already the ones where people come on this peak. So the same peak as we have on here. And you cannot really overnight it. That's all that can be the same material. And you also don't to say that.
Yeah.
So this is same ceiling, so you cannot overtype.
So the ball inside is different.
The ball inside is different. This is silicon carbide.
Silicon carbide.
So SiC.
SiC.
So
now we can install the Optimus check valve as
much you can use as much force as you need. Unfortunately, this type of check valve, and that's what I wrote Elton, I think 1 or 2 months ago. Since at least 1 year, I think there is a problem in the diameter of the ball compared to the seat. And when the check valve is not sealing properly anymore, or the ball cannot move as it should, it influences the flow rate of the pump. So therefore, we observed, and you observe the same on customer side, that when you are installing optimized check valves, but not all of them, it is only about 1 year ago or 9 months, I don't know exactly what it is, you observed a lower flow rate.
Yeah.
Which then in turn is the same as when you would have a leak. Shifting everything from Oshimoa to higher retention times on the HPLC.
Higher retention time. I thought it's earlier.
No, later.
Later. Because lower flow rate.
Lower flow rate.
Push lower. Okay, later.
So later retention time. Therefore.
So that is what you guys experience.
So the fraction will move further
to the back, but unfortunately to a time where it is out of our transfer window.
Yeah. So it should be left of the fraction.
Yeah, it would result, for instance, in loss of, for instance, parallel. Yeah. This is because of the lower flow rate caused by a problem on the check valve balls. Because for your explanation, the silicon carbide balls are not produced by Optimize; they are produced by somebody else. And the seed is done by Optimize Tech, so they have all their knowledge on that. But the ball is bought by somebody else, and there seems to be related on a batch of these balls. Since these balls are not exclusively produced for Optimize, it was not possible just to switch to another batch. Also, it was not possible just to produce a few of them, because it seems to be a quite complex procedure to produce them.
Opposite way or higher.
For what?
So now the ball size and the seat is not highly not fitting perfectly, so it will maybe give a lower flow. She's asking whether it will give a higher flow instead of lower.
So in fact, what we did was, of course, first of all, we tried to use the compensation factor in the pump. Each pump has a factory compensation factor for the flow rate of each pump head. You can set this factor up to 9.99, which is the maximum you can do. Yeah. But even with that, we were below 300 microliter per minute, so 0.3 milliliter. And of course, you can then start to change your lab solution method to increase from 300 microliter to 320 or whatever. But this means you need to adapt for every customer each method, and when you change the check valves, you will start again, which of course was completely out of scope. Therefore, as a short-term solution, we advise you to switch back to the Shimadzu check valves. They work normally quite well for, let's say, maybe short period of time, but only for, let's say, immediate period of time. As long as the charge build-up is not big enough, they work fine. But what we observed with all customers was out of the sudden, they stopped
the ball
working. Because the ball, in fact, Shimadzu check valves are based on 2 balls and a spring. So there are 2 balls inside, 2 seats, 2 balls, a spring. And I don't know which part is charging up, but as soon as the balls do not move anymore, not have any flow anymore. What we now came up with, also an idea of optimize. So we have again working optimized check valves. But when you look on the layout, it's looking completely different to the one you have before. Just to compare it, it is using the same housing, so you can just put this one in the same housing. But just show them to everybody. Old one, new one, and this one has 2 balls inside.
So this is using a Shimazu design.
Nah, it's not a Shimazu design.
Something like Shimazu check valve.
Yeah, so this one is now using 2 balls, no spring, only 2 balls, but 2 balls of silicon carbide.
Okay.
Yeah, and with that one, so at least up to now, I only got 8 prototypes. We got the first batch from the United States, I think, last week, but all of them just work perfectly fine. So I'm very confident that we can now supply you with this design, which has 2 balls inside, which compensates for the problem. This one here only has 1 ball, which means when 1 ball fails, the check valve doesn't work anymore. On 2 balls, seems to be easier, seems to be more stable.
But is the ball still manufactured from different company?
It's in fact, it's the same ball here and here, only two times.
It's just a design different.
Yeah.
So now have 2 sitting.
Yeah.
Then my question will come is how often do we need to change? If with the new improved design, do you see a better robustness or better longevity?
So
this batch?
Of course, since we just started on that, it's hard to answer the question regarding if the next batch will look the same.
Yes.
Honestly, I cannot answer because I'm not the producer of that. But up till now, every cartridge I checked was fine.
Is it more expensive?
A little bit more expensive, unfortunately, yes.
It can last how long this?
As I said, now when it comes to the longevity of check valve, also of its sealings, it is interesting that you are seeing failing pumps because from the solvents, they should not fail. From my experience, it's because customers remove the fritz on the entrance of the solvent bottle, or you get dirt inside your pump. But the check valves do not have much pressure they need to work on. So I personally, my pump in my company, I think I never changed sealings and no check valves in more than 4 years. So when you see that failing on a regular basis, it's because something else is the cause of that problem. And in my experience, it's mainly people are refilling the bottle and are not maintaining, for instance, on top the scud filter and also not the filter inside the solvent. Because when I think I said that yesterday on Monday, I'm not sure, people somehow have the idea they need to replace the filter on the fridge of the solvent bottle.
So it's a possibility of users are changing the Optimax check valves so frequently because of it.
I suppose it needs to be something else because from the chemical point of view or from the tear, from the wear and tear, we only have 40 bars. You have seen this is very little for an HPLC pump. And the sealings and also the check valves should normally hold much, much longer.
So that level is fine.
That level is fine, yeah.
Maybe I didn't catch them. So this one, like this is saturated, it will affect the bottle. And she might not only that, but also things like the bottle.
Because of course that will saturate over time, especially what you also have done yesterday evening. You are opening the bottle and you are refilling. course, you will get the dirt inside.
So the best practice is actually it is like approach the bottle that
Yes, the best practice, of course. I have to admit, I'm doing it also the same way as you are doing. In this case, you need to have, I don't know, do you have any specification for the lifetime of your filter inside the bottle?
sorry.
Yeah, then you should also do it on a lifetime instrument. Because I do not know if anybody ever replaced those filters inside the bottle.
With PMP 6 the filter comes with it.
But you will replace it also?
Everything comes with the case. Replace everything.
Also
When
for
you do
a
this.
smaller instrument. Because one problem on the filters is what we also observed in the beginning, they can be contaminated with more. So when you change the filters, you first need to clean them before you change them. Because otherwise you have a contaminated filter in a solvent, and then you are thinking, okay, my solvent is contaminated. You're taking the next bottle, again contaminated.
So meaning you take the filter, maybe sonicate with vaccine.
Yeah. We are doing FIT when we're setting up an instrument. We clean all filters
With vaccine, sonicate.
Yeah.
Then few times.
a few times, and then we are installing it.
Yeah, we often wear gloves and COVID. And so
Yeah.
this one we need to change it because the moisture.
That's because of the moisture. Yeah.
That one is because of it will affect the
Of
very
flow, also mainly because of dirt.
dirt.
It is mainly in this combination mainly dirt, or let's say dust. It's mainly dust.
But the one that we have a Philippine customer keep on complaining, they are keep changing the feedbacks every 6 months, every 3 months, and then the plunder sale recently was spoiled. Yes. No. DNL.
What I do it.
The one is
I don't know.
okay. So it's a similar case as what happened in Malaysia.
Mhm.
So we spotted the plunder sale. We spotted some brownish with that. So that one erosion monitoring in coffee. But it's a check of their complaining because every 3 months they need to replace the cartridge.
Yeah, but it doesn't make much sense. So I have no idea why a check valve by itself should fail so fast. I think it will be some build up of dirt or whatever, of course, inside the check valve, because as soon as you have dirt inside, it will not close anymore properly. Normally, when they sonicate it, does it work again?
Yes, it works.
Yeah.
After that, you get stuck.
Yeah, they have dirt somewhere. And the question is, does it only happen on one channel or on both? Only on the dichloromethane or also on the hexane side?
Yeah,
Because when it's dirt, I suppose it happens on both sides.
Everything. I think I do like that.
So the Shimazu ball is made by
Ruby.
Ruby.
So you have the normal ones. It's made. So the ones here. So this one here inside. There are 2 Ruby balls.
Oh.
For the X3 pump, you have typically ceramic balls. But ceramic has the same problem as it's not conducting. You are typically using ceramic balls because ceramics has a higher density. The material just weighs more than the Ruby ball, and this is an advantage when you are pumping a C2-nitrile, because the C2-nitrile tends to polymerization, which is the typical problem when the check valves do not work anymore. Because it is forming some kind of polymer on top of the ball, somehow sticking inside. And therefore, the advice for all vendors, it's not an invention of Shibatsu, is to switch from from movie balls to ceramic balls. We tried also them, of course, in this scenario. Of course, what we expected exactly the same lifetime as the normal Shimadzu check valve. Because one important factor seems really to be the electronic charge issue. The second one, as I said in the morning, what I was not aware of in the beginning is the temperature rise of the pump heads when the cooling inside the pump doesn't work properly. So it's a combination, at least of these two factors. Doesn't mean that there couldn't be a third factor or a fourth one. And what I could also really imagine when customers are seeing a failing dichloromethane channel, also with production of HCl, you should check the temperature of the pump head. Because I can imagine that formation of HCl would be much higher when the pump head has a higher temperature.
So that temperature link is the factor.
Yeah.
Make sure so can you use the check valve?
You can on the pump, you can,
Okay.
but unfortunately, I would think that it works maybe 3 to 6 months. Then you need to pump at least one time discharging solvent through it, either on the pump or in a sonicator. So you need to
wash
use
IPA.
something like that. Discharge the check valve, but at least then you can put it again.
Every 3 months.
If you use something such as
But that's at least our
recommendation. We need to check all those.
because at least we also with the old optimized version, when the ball seat issue was not there, we got much better lifetime of the instrument compared to the original Shimadzu check valve.
Yeah.
That was at least our experience.
Yeah. But I think XML experience is a different way.
Mhm.
Maybe because of the filter or whatever reasons, we are not sure when the Optimax will fail. So they choose to use a Shimadzu check valve.
Yeah.
At least they know periodically 3 months they will need to clean one time.
Yeah.
Communicate with IPA, something like that.
Absolutely. So when you are fine with that, when you can live on the fact that you need to
Clean
it on a bigger place like every month, one time, absolutely fine. But at least, honestly, because of the very little space you have inside the pump, and what I personally really don't like is the stainless steel connection on the outlet check valve.
Yeah.
I don't really like them, especially on pump at A.
Yeah.
There's so little space when you need to replace the check valve.
It's very difficult.
Therefore, I prefer, and therefore we decided to use the optimized check valve to have a longer lifetime. But if you're fine with that in communicating that every 3 months or 4 months, it really depends on how much the instrument is
Using.
in use. Because electronic charge off is when you use it longer,
faster.
it will be faster. Then you can stay without any problems on standard on standard check valves. Absolutely fine.
What the problem will be noticed the check valve is that
What is the indication or sign symptoms?
It works on the one day and it doesn't work anymore on the next day. So you will just have pressure fluctuation or no pressure at all.
No flow at all.
No flow.
is it delayed?
High pressure?
Yeah.
No, high pressure, no.
From the
This is some clogging then.
okay.
But high pressure is typically not coming
No flow.
from the check valve. Because to get a cloggage in the check valve
So
would mean
So it's like
you need to clog a channel of a diameter of, I don't
No
know,
pressure
1
at all.
millimeter or something like that. That's very unlikely. When you look on the diameter from the housing, that's the same for Shimadzu, and also you can see this is a very big hole. Also here is a very big hole.
Yeah.
So clogging inside here is essentially not possible.
Oh. So this will only affect the flow.
Yeah,
It will not
Yeah.
stop.
Because when you have dirt inside or particles, it will first of all affect the movement of the ball, and this is much earlier observable than a complete cloggage. Yeah, so you will first see that the pump doesn't even pump anymore, but you cannot accumulate so much dirt that it's completely clogged. I think you will see much earlier that the pump will just not pump anymore.
So meaning we have zero pressure.
Yeah.
Or the base
Yeah.
of the pressure
Yeah.
is
Exactly. Exactly.
Okay. Yeah. So if one check out like see like baby and then very low pressure.
I want to make sure you learn how the very high pressure.
Oh, high pressure. Somewhere. Oh, the charge. Yeah. I think you explained just now why the charge is happening in the.
How do you ask it again?
No, absolutely. It is because
You know what I
I don't know how to explain.
stain by itself cannot
and then we
conduct.
Yes.
Yeah, so as you know, hexane and all organic solvents which are not polar are not conductive.
Oh, mine is a whole bag.
Right
Right after we know the problem.
which can
But I really bought it.
creating charges
That's why
just by doing that. And in
the previous one
gas
like,
are
cannot like
work in a way
too much
that
and
we
now
have
your
fine
one you
weight of
Yeah,
the
this one can tighten.
what's the difference?
As you know, the gas is working in a way you have fine weight of
Yeah, yeah.
PTFE has the advantage it is
Wait.
non-penetratable for liquids, but it is penetratable for oxygen. So when you have oxygen or air inside your liquid in a PTFE tubing under vacuum, the Vigasa has a vacuum under which your PTFE tubings are. The oxygen is penetrating through the tubing out and can therefore be removed from the solvent. But these are quite fine tubings compared to that one. So when you now flow with a quite high speed through these tubings, you are creating charge inside the tubing. These are then flowing down to the earliest convenience where you have metal parts. And now I have a look where the first metal part is. Exactly.
Okay, and then it's carry the charge.
Yeah.
Take one.
Yeah.
But I don't think vaccine can conduct.
Yeah, but I don't exactly know how the it will start to somehow. I don't know if it is the complete tubing or if it is just a matter of time, or if it is also the residual humidity inside the
ตัว
has not
มันเอาไปที่เช็คเปล่าต้องเป็นคนทะเลมันก็มีผลต่อการทำงานของ
this observation
เลด
เปล่า from the etulet, and as soon as which normal phase check values, which are also based on some similar material, the problem was completely gone. PP is doing the same. So also that one is doing the same. And also don't forget PP cannot be
Used for motor.
Yeah, but yeah, not only for
What we tried was to replace all of the bricks against stainless steel. That is what we tried. Yeah, works better, but it has clear disadvantage to the customer. Cannot see anything anymore in the tubing. Yeah. So I did this only one time, and I realized, okay, a cool instrument is doing what it should, but you cannot see bubbles anymore. You can also get conductive PTFE. This is then black colored. Nice, but you also cannot see inside the tubing anymore.
We check that before going into the.
Yeah, the problem is how do you want to make sure that all the liquid is
Discharge.
discharged. You need to have some grid or something like that, where the liquid is flowing through a metal grid or something like that. Then you need to discharge. Honestly, no idea if that would fine. Also, depends on the full, on the mesh size. So you need to have a very fine grid, giving very much of a high back pressure, or let's say restriction. And as you know, the low pressure side must be essentially without any restriction. Otherwise, the pump cannot aspirate anymore.
Oh, sorry, I try to get back. How you guys realize it's a charge? Because after you switch, you say you switch the accident to normal first phase.
Normal phase check.
Normal phase check. So what's the difference between normal phase check?
Check-well was only the material of the ball inside.
Material of the ball.
Everything else in the design, at least on the Agilent side, is the same.
The material of the ball cannot be charged.
True.
So that's why you know it's charging.
At least we know for sure on the Agilent equipment. I always thought it is the only course also for Shimadzu equipment. Now I know it is at least, let's say, minimum maybe 50%, because at least at the moment the other 50% are because of temperature issues. As I said, could be even a third cause. You never know, but at least I know these are the most important factors at the moment. And to be honest, the easiest solution would be when Shimadzu headquarters would just produce a check well with a wall inside, which would be of a conductive material. So conductive, non-stainless steel, of course, because it would be too heavy. But you have like silicon carbide. That is kind of a ceramic conductive material. We made this suggestion, I think, now 13 years ago to Shimadzu. That's all I can say.
What's the material on them? The one is ceramic, the other one.
Which one? Yeah.
The one you say you change it, then you will buy it.
You mean on the Agilent one?
Yes.
Agilent one is also some kind of silicon carbide. So the easiest way would be to produce and condition as standard Shimadzu check valves, just switch from ruby to conductive material. If it then works well, we know we solved it. If it does not work, we know it's something else. To let you know what we also tried is, we opened a Shimadzu check valve, we placed the walls against silicon carbide, and they worked. Yeah.
It's the idea to be
Yeah, but only by me, not by Shimadzu. And to be honest, this needs to be done by Shimadzu. Yeah,
by no charge.
yeah, yeah. It's not inert, but it can when you have a build up, it can be discharged to the metal surface. It is not building up any charge. Specifically, it's the charge built up the seed, because the seed is typically made of zirconia, and the ball is again for in the normal ones ruby, and you have a charge of plus and plus, so the ball sticks on the top, and you have no movement anymore on the ball.
That's why they throw.
Yeah, and of course, when you flush them or when you sonicate them in, for instance, isopropanol or ethanol or whatever, hexane does work. If you need something to discharge it,
That's why you guys choose
then you can put it again, and it again works fine. Yeah. That's unfortunately very easy and only for pure alkane as a solvent.
I want this thing. So I think this whole episode we ask for the one about
I had this one very often, and
มันบอกไปที่มัน
just had the idea, well, why why don't I put 1% isopropanoate into it? Would try to lower the problem, but it doesn't work anymore on the silicon bicarb. Sure.
This need to change the house.
Not only that, but maybe this part here after each injection.
Maybe again.
ไม่เวิร์กอะไรคือถ้าเป็นขนาดให้ระยะยาว
You differentiate between the old one and this is the new one. Okay, the old one, the new one we can tighten up. The old one is a different design.
Yeah, I can show you in the slides because it can be seen very easily.
Is it the white color?
White color.
Ah.
White color is a very soft material.
Okay.
When you tighten it too much, it will just be squeezed,
Okay.
and you are not sealing properly anymore.
Wonder. I think my one is
White.
mix of white and the.
Okay.
Oh, okay.
ตรงนั้นไม่ได้
Yeah.
also มันมีบอล
Then you
มัน
need
มีเสียวตอนอันนี้มันก็เลยต่อมาดูเลยคือแล้วที่เขาไปไม่มีปัญหาเรื่องเช่วยนะเพราะว่า
Think back. Then you can assemble anything back by close it. Unfortunately, this typically needs to be done in a complete dust-free environment. Of course, this is a very basic
ไปไหมตัวใหม่
I've done, and you cannot open it anymore without
ช่วย
scratching
กด
the
ก็ได้นี่มันตุกเสา
so that
มันดีไซน์มาใหม่ด้วย
and
คือดีไซน์มันจะมีนี่มันโผล่ใช่ไหมที่เราบีบเยอะไม่ได้เพราะอันนี้มันโผล่ขึ้นมาเกินใช่ไหมแต่ตัวใหม่มัน
no,
มันจริงๆมันตื่นไง
very dry on that.
มันเข้ากับป่าจริงๆมันตื่นไงจริงๆมันตื่นมันก็ระเบิดเหมือนกันซึ่งแต่เล็กๆกว่าไม่มันคือต้องนิ่มแต่ตัวเล็กมันตัวใหม่ไอตัวเก่าตัวใหญ่ตัวใหญ่ซื้อตัวเก่า
Yeah, but the others
ลูกไปดูก็ได้
experience.
อันนี้คือตัวเก่าใหญ่ๆใช่ไหมใช่
Okay. So now this one you can tighten.
Anything.
Then this one,
So we went.
the old one is white color. This one you need to be softened. You cannot tighten.
มัดนิ้ววันนู้น
This one you can tighten.
this
No. It's the same. Even this one, right? The current, the one that I bought, right? This one you can tighten all the way. It's because the material. This one is big. Yeah. So you can.
So this one is new. This one is very very new.
This one is a new design, not yet come out.
Now you come.
You cannot buy.
Yeah.
What you can buy is this. So you only can buy this one. So this one is inside.
where you get it
This one.
He what?
He bring.
I think you already have
No. So what is the difference between these two, right? This one ball. That one ball. Yeah. It's a new design. They are
in the
trying.
future
Maybe. But future. Very future.
About conductive problems on the FIT here.
So you just need to look at the color.
But I'm pretty sure that
If this one is a white color, you cannot tighten because the material is soft. It's a big color. Yeah, like this one, big color. This one a bit yellow. Then you can tighten.
อ๋อ
You can install like
you cannot if brown yeah
this color.
Uh-huh.
You see white. This one you cannot tighten. You remember Mr. Tu say you need to saw.
yeah
That little tight. Yeah, that's because of this. But this one is okay.
I need would try it
Yeah. This one is okay.
because maybe you have the practice
I would do the same, or I wouldn't do the same.
you want to see ใช่ไหมสีถูกป่ะใช่ออกมาดูแคมเปญ
Yes. Then open up.
sorry Oh, so all these times.
So this is the one that
Scala, you cannot tighten this. It's basically when you just look into the installation sheet, what nobody does, it states finger tight at 90 degrees more. Then also these work perfectly fine. but nobody just reads the
Yeah.
fucking manual.
They just around like finger tight and then they hit it.
Yeah. No one read.
No,
Yeah, I can assure that.
ก็คือให้แล้วก็ก้าวหลัง
Like here.
it is finger tight, and then once the housing is hand tight and a quarter turn
Yeah.
with
Wrench.
so 90 degrees.
Yeah.
But
But it's not needed for this, right?
No, this one you can, if you want to,
180 degree.
yeah,
Fine, right?
if you can, try it.
Okay.
ก็คือวันที่ออเดอร์มีแต่ new
ถ้าเกิดตัวนั้นมันไม่จำเป็นไงคือตัดเท่าไหร่ก็ได้
the new order will it be the new check box
How new you want?
yeah how
This
new the check
this one or 2 ball or 1 ball?
ball will it be the 2 balls one
Yeah, up to right now we are only installing everything already on the 2-ball system.
So the new Malaysia
Should be. I think we got the first bigger delivery of the check valves. I think last week.
So you can look at that lah. You see lah. Then you know lah. On site.
I overheard your conversation with them. That means right, because last time when Mr. To is here, right, I saw them very careful turn this one.
Yeah, of course. When this one, but
So now we
honestly,
don't care.
when you just do it as in the manual, also that is fine.
Depends.
So this new one when they don't be damaged. Well, I saw the sun they were very
Yeah, when it
This
is
is a big
peak
material.
peak is a very hard material. You cannot crack it. You cannot over tighten it.
It's very soft.
previously different. Oh, it's not big material.
Yeah. Then you can only like 90 degree turn.
ทีนี้ใช่ป่ะ
So that this time we can
Yeah,
like the quick
yeah.
moving a bit.
just inside, I don't know 180 degrees.
ดีกว่าด้วยเพราะ
Whatever.
ป้าไม่ได้เลยบอกเสียเลย
There's a lot of time when I receive this one.
Hey, recorded.
Yeah, it's recorded.
But then it's one only twice. Optimates.
You can see it by the. Of course, you cannot see balls, but they look completely different.
All this is
These are multi balls. It's not fun. It's not when it's you don't see it anymore. But it's a little bit like yeah, very hard out of the sea of but you can with 3 exit points.
Oh,
Yeah, that's
it's not from the train.
one. This is only one and one I
So this one got two why?
Oh, this one has one entry, one exit. The new one has 1 entry and 3 smaller exits.
Oh, I saw 3 holes. You have to zoom in very. Oh, it's right. 1 3. Oh,
1 3 1
top 3.
all 1 1 1. All 1 1 1.
Oh, I think the other side. The other
อัน
side.
นี้วันโอน
Oh, 3 hole.
Yeah, 3 hole.
Yeah.
It's really 3 hole.
1
Yeah.
and then 3 hole.
Oh, it's not wide. It's a 3 hole.
It's a 3 single.
It's 3 hole. But here cannot
One
see.
is center.
Yeah. Oh, it's 3 hole.
So we can
Oh,
review
okay.
This one is only 1 hole. So 2 sides also 3 hole, 3 hole.
ไม่
One side makes one side 1 hole.
ตะแกรง
The other side is usually 1
1 hole. So which one is in? In is 1
in is 1.
One is one hole. You can also see it on the side on the arrow here. So it's I think inlet flow is on 1 hole and exit flow is on 3.
That should be a arrow, right?
Yeah, here.
Oh, okay. We need to.
Here this.
Have you tried? Have you met any customer that
put in the
So
wrong
this
direction.
one, I need to put it this way.
It's won't pump anything.
Okay.
Yeah, when it is, yeah, it will be open then all the time. Yeah, because the seat
Yes,
seat
got direction.
is shaped like the ball. So you have this seat, the ball on it, but when you put it the other side,
Oh,
the ball here,
Yeah.
here. Yeah, so completely open.
So this one I should put like this.
Depends.
And then we open from the top.
So first of all, the good thing is when you look on the thread, there is two type
Yeah.
of thread for the inlet and for the outlet. When we talk about outlets, it's always the flow direction. So it means when it is on top, the arrow needs to show to the upper side because the flow of the liquid is in this direction. When we are on the lower side, it is that way.
So I need to check in before I.
Yeah.
Jenis free macam ni juga. Tapi assistant kalau kau pasang tu balik.
Or one very big hole.
Maksudnya bila kau pasang one kat dia punya housing.
Or one hole.
Balik.
All one.
Dia akan bisa one. So one ball. Ini kalau kau pasang tu dia akan flat lah.
Same concept.
所以那个一个那 arrow 在哪里啊？上面 OK。哦。OK 可以行。所以它 exit 是三个洞 ，enter 是一个洞。
I don't think so.
Too bad my pal don't have this one. Now can do a lot of fun. We're complaining we don't have a solvent dryer. Have to use Kronos control, so we can't. Lazy to control it.
In the future, for us, starting from now, I think under this number, you will get always the view.
Sometimes you have a bit of communication breakdowns, like when you're changing something, but then they are not aware. They're only aware during the exercise. Change, check out is change.
Area gas change?
Something like that.
Yeah, previous unit. So yeah, this is previous unit. So let's say when we change the and then the criteria in the SAP, there's a change when evaporator pressure.
Sure.
Yeah. So we are not aware of that before we are there to perform this.
So the main issue for carrier gas is that we do not even get the information from you guys which carrier gas shall be used on the customer side.
Yes.
So when we do not get any information, we are doing it all on hydrogen because I would say 99% of our instruments are based on hydrogen. When you know that's also the same problem for our own sales guys. We need to ask during the order processing if the customer is fine with hydrogen or if they want to have helium. When you get this information to our sheets, then normally we are doing also FHC based on helium. So then of course, yes.
So for the ISF case, I'll inform them both is helium as well as is one chloroform.
So that's another thing. When you want to have a specific old method.
Yes.
Yeah. So for instance, the customer only wants to have MCPBA or they want to have chloroform or whatever. You need to put that information specifically into all the sheets because otherwise we will just assume the customer will have the newest version of the stuff. Because otherwise it would mean we need to do FAT 3 different times. But of course, we need, even when an FAT doesn't need to be repeated, it needs, I would say, only for the measuring time, about 48 hours or something like that. And unfortunately, it's done not only one time because there are mistakes or things that need to be redone. And that, of course, it's very complicated to have that at different conditions. So when you want to have the instrument in specific older configurations, like chloroform or something other like a carrier gas or whatever comes to your mind, please be assured or please be sure that all the information are written in our, we have this called,
OS or OIS scripts.
I don't know how it's called, but something like that. Yeah.
Okay.
Also, when it comes to the question if a customer wants to have FAT on, for instance, ethanolic MCPBA deoxidation, because normally what we have done this morning, this type of analytics, also as I have explained in the slides, is normally not done by many customers anymore. So therefore, we typically have not it anymore in our FAT procedure, and of course also not on the SAT side. But when it is a special request, of course, we are doing FAT also on this method. But typically, we are not doing that.
If we see through the FAT documents, right, there are tabs for a basic CGC and then there's a box position.
Yeah.
So that means ethanolic FCPA, right?
Yeah.
So that means if customer doesn't want to use FCPA, you will not.
We will not put anything into these sheets. Of course, they are present all the time, but you will notice that no information are inside, no numbers, nothing entered.
Okay.
Yeah, so it's then here for epochs and
有啊，是对，哦，你现在是没有，还在没有，有，应该这是没有，应该有，哦，应该是吗？你看，
this one has aluminum oxide test and performing epoxidation.
And then for the first template, it is performed on
you
Yes, for all instruments.
yes, yes,
We're done on the outside.
correct.
We have slides for that. Yeah, we'll talk about it. Also for the guys. I don't think that, but we will talk about it later. This is all done on the basic configuration, small assembly. As you might have noticed for the like workflow, there are other examples down there
You just got your black
with the big
is right there.
we don't do any because essentially we are doing exercise because this linearity of the instrument. So all this stuff here. Honestly, I just implemented for Shimatsu equipment because we had this problem on the linearity for the FID. Therefore, we are now checking at 4 concentrations, and we are checking the response factors that need to be below 5%, because otherwise we are observing non-linearity for the FID. We are performing this also for so this is now done for because also Esther customers have observed such issues, not because of same off, but also similar issues. Therefore, we have included the test that is done for all FATs. But this test was introduced when we found out that we had problems with the also something like the training for Meridian on the HPLC color. This was also introduced for Shimatsu equipment before we found out that we had the problem with the metal ions. Because when perylene is transformed into chloropyrene, you do not have a symmetrical peak anymore. Chloropyrene has a little bit higher oxidation time, so it will start to tail.
How do you actually do this? Because you don't have a mass spec.
By GCMS.
Oh my gosh.
I did track and collect, and I looked at the compounds that I could see, and then I found chlorinated perylene.
So you just take it. Yeah.
It's called.
How you think adjusted?
They're trying to check.
This basically is something we also have observed.
I just say
I have told that we are using at least pH.
Yeah.
Also at the beginning of Shimatsu equipment. So it's then HVDC with the Shimatsu Singapore. When we when we are doing
Okay.
so LCGCMS,
Okay. Effect of it.
and we observed that we are losing PAHs, which are not there anymore.
Because
Because of chlorination. Then I looked at that and found out it's not only perylene, but essentially all PAHs can go into this.
also reacted with the Fe and then formed something
Yeah.
else.
Therefore, also on the pH instrument, we have an ETA trap.
That's curious. What's the loss due to chlorination? Should be very little, right? That's an estimation.
For Moshmoa, yes. But when we talk about pHs are analyzed at a level of microgram per kilogram, so ppb. And customers are analyzing typically at the range of 0.1 ppb, means 100 ppt. And 100 ppt can be completely lost. So peak is completely gone.
So that is due to the LC pump.
Yeah.
Nothing to do with the
Yeah.
CMS.
Yeah.
Wow, very interesting how you figure this.
Yeah, again, not in one day.
And understand she not really more than that.
ในตารางก็เหมือน ppm ดับเบิลเป็นเลี่ยนอย่าง ppm นี่คือฐาน ppm ฐานแสน
ด้วยการ
2 ล้าน2 เท่า ppm วันเป็นเลี่ยนพันเป็นเลี่ยนm ครึ่งเลี่ยน
PPT
สูงสุดมีลองมาที่น้อยสุดเป็นเลี่ยนแบบนี้คือเลี่ยนก็ไปทีละก่อนนะคือทุกอย่างเรานั่งนึกก่อน Google
right technique right or not
ไรหน่อเนี่ย
Do not need to know this now.
Yes. So
If normally when I would have had more time in the beginning, I would have done all this before, so that I have more time for you to explain stuff. But I'm pretty confident that we can inject the samples. Okay.
confident on what is
No, I think
I remember you were many believe in the Chimater. Wow, you guys here.
Actually, yeah, it's correct. I mean, Shimazu Jawa can be used. It's just like periodically you need to do the cleaning to clean up the charge that build up.
So typically you are using this time to inject standards. Yeah, so injection kind of standard.
It's not
Yeah,
because
then it can inject the samples afterwards. So normally in this time you can check the instrument.
So it should be running.
Yep.
จะมีอีก7 นาทีก็เสร็จแล้วพอเสร็จแล้วเขาถามจริงๆน่าจะถ้าเกิดไม่ถามว่าไม่ถอนในที่ตอนจริงๆน่าจะเป็นผู้ดึงนะอันนี้เขามาดูไงว่ามันทำโอเค อันนี้ก็ต้องมาดูว่าเห็นไหมมันได้ไม่ได้ตัวเลยไปไม่ใช่เกิดมันมีอะไรผิดพลาดติงงองเนี่ยใช่
ต้องใส่เย็น
สุดท้าย
ดูเดี๋ยวไปใส่เย็น
เฮ้ยเขาโต๊ะมันนิ่งมากโต๊ะเรามันเขย่าพี่ว่ามันเนี่ยโต๊ะมันยาวไงมันก็เป็นถ่ายวิดีโอมามันก็ไม่ชัดพี่ว่าเป็นเพราะโต๊ะแน่เลยที่มันจับติดไม่ได้เพราะว่าคือถ้าสมมติเราเตรียมเอฟอย่างเดียวเข้าไปแต่ว่ามันก็เตรียมแค่ใช้เข็มของมันใช่ไหมแต่เนี่ยพี่ตัดด้วยเอาได้มันทำเอฟไปด้วย
แล้วมันทำไมนะ
มันจับเข็มไม่ได้
เดี๋ยวไม่ขนาดนั้น
สั่งงานมันยาวเลื่อนไปเลื่อนเร็วอ่ะมันขึ้นว่าจับเข็มไม่ได้เลยแต่สามาพี่ก็แบบเอ๊ะอะไรวะแต่มันโยกไปแล้วมันสั่นอยู่ไม่พี่ไม่เห็นเวลานั้นนะมันไม่ได้นะคุณปุ๊บพี่
หักไหม
ดูเลยนะเล่นแต่สามได้เดี๋ยวว่าบิดไม่ดี
เขาได้พักผ่อนไหม
ก็ได้เดี๋ยวไปถามก็ได้
มีอะไรเยอะ
เราต้องมาเรื่องของเราอีกสักเราต้องถามอีกหลายคำถามเพราะว่าไอ้เรื่องที่ตัวเว้นที่มันเกินไปอ่ะเดี๋ยวก็ต้องให้เขาวินิจฉัยว่าเราจะแก้ไงให้ผู้ชำนาญการวินิจฉัยให้ของอะไรอันหลอกกันนะผมตกข่าวทุกอันเลยนะหลอกเนี่ยเรื่องอะไรเกิดอะไรขึ้นบ้างเลยเนี่ย
ทำเลยนะ
เขาอยากถามวิตามินบอกว่าeverything's up from here.
Yeah, that's a CTC problem. Can be problem with the contacts on the tool.
Oh,
So this is not very far, but most likely these contacts here. So the arm that mounts the tool will not have any electric contact because here's the human side. Inside the block connected by these 4 pins. These 4 pins cannot have electric contact. You are getting this message. Yeah, maybe what you are seeing where let's say when these are gold contacts with the spray cables. When these are not put anymore, then it can work one time but not the next time. Yeah, so that is the very first observation. And the next observation would be you need to send us diagnostic data in Sonos, and we send them to CTC in Switzerland so that they can look into the data to tell us if something else on the instrument is not okay. But you need to send us the diagnostic data of the instrument. So I'm pretty sure somebody has shown you how to do that.
I don't think it's in the log that you get.
So first of all, also this is part of the training. But I'm surprised to hear. That nobody has shown you that, because that's the basic requirement. When we need to support you, we always ask for the diagnostic data in Kronos. From Kronos. Yeah, but then when you send it to us, what's the answer?
I'm not sure about that. But I think I will be already talking. Got to make it I'll be great.
Okay, but then we need to I need to get the answer of Mr. Chu or what CTC told you, because now I can only guess what the problem is.
เขาบอกว่าเอาตัวเองที่เป็นที่บอก
แล้วก็บอกเขาไม่เป็นประตู
เขาถึงไม่อยู่เพราะว่าเขาไม่ได้ถอด
เพราะว่าตัวเขาเป็นเรื่องที่ต้องคอนแทคตัวอยู่คือบอกว่าสถานที่โชว์แอนด์ว่าแค่เด็กที่ไหนที่เราเที่ยว
ไอ้อีกออกได้ไม่ได้ของเรา
ได้เลยเขาบอกเดี๋ยวว่าให้ทำแต่ตรงนี้
This is very tough. And they would
แค่ที่สองก็คือไอ้มันเป็นเรื่อง
say
ต้องทำตรงนี้
say and then
ที่ปรับตัวอะไร
เขาบอกพี่เขาเลยเขาไม่
something like that. Takes what kind of me.
โซนออดไปไปเห็นเพื่อน
ไม่รู้ยังไม่เป็น
You need to clean it because especially like change we have one
เปิดมาแล้วมีชื่อในชื่อตัวอยู่ในเลยเขามาให้ผู้เป็นพันจะให้ไป
So I tried. Mr. Tu teach you how to extract from the chronos?
Yeah, just that.
Just.
When we found program, I had to Mr. Tu.
Okay.
but he never teach us
Or during the
Anyone-
during the installation, no
Our
lah.
program,
Is WhatsApp. He will teach you through WhatsApp lah.
yeah.
Ah, sorry. Maybe Chige will be the best person to teach you.
I think he don't help
See lah. Trust and application chemist. Maybe you show him how.
Again, it's like, but then you have very high chance of contamination again of the filter of dirt of somewhere. So normally what I do is I unscrew here so that when I'm unscrewing the connector here, that the filter stays inside the bottle. It all comes down, from my experience, when it comes to the lifetime of the pump, either old solvents, so like dichloromethanes, which was in sunlight and 2 years old, something like that. Hexane is not so problematic. Or they remove the filters. So to be honest, very basic stuff.
Just ask. Regular got issue.
So which here, easy.
What issue?
Mister,
If you ask me, sorry,
this one.
if you ask me, you should use those because they are all made of glass.
Can see.
This is all glass, yeah, and you can see inside the filter.
So normally during shipping to us, you use the standard smart one.
We take the ones that are coming with the instrument, and we are cleaning them. No, we do not replace them. We are cleaning all filters, but we keep all filters as they are shipped because we do not change anything.
you want to do any injections?
Yeah.
I don't think it's done.
No. It is done. It looks nice.
Yeah.
We just now need to inject
I need
samples.
Sergeant? Oh, injection.
There's not only some
So here, that one. And now I think somebody of you has the picture of the slide.
Yes.
We need to put the 2 injection lines
Okay.
in there. I think that looks nice.
It's all right. Then when you can categorize the children, then you know how much I think that. So you have to talk to each other.
Is it okay?
I think
It's not, I don't know. How many?
How much is the injection portion?
In the picture, it was only 100, but you can just do 400. Everything we can. Now we are doing now everything we can.
Your sanction.
What about it? I never have the.
Please.ไม่ชอบเป็นthe loss.
Well, supper
Thought is the one and two.
1 and 2.
Finance. Yes. Like
Then issue ให้
sunflower. Region Frank.
แต่ว่าแบงค์เธออยู่วันที่1ปีแรก
ใช่ใช่สิคนหนึ่งถูกไหมถูกไหมครับโอเค
I said no I think they really because of the video on Google correctly on the but they complete
เราเล่นเป็นแข่งคน
ใช้เป็นเดียวกันดีแรกเลยอย่างแบบสิ่งตู้
อันนี้เป็นความก็ได้ไม่เอาต้องแต่ไอ้เองไม่เอาเราแค่นี้พอแต่ไม่ต้องไม่ใช่แค่นี้ไม่เหมือนกันคนละตัวละฟังก์ชัน
เขาไม่ได้สอนเซ็ตเอาเลยเขาได้สอนไป
ดูตอนมอนอเขาสอนแต่อะไรแต่จริงๆเราไม่ได้อยากเลือกเป็นทั้งเป็นบอสแต่ว่าเป็นคนตอบขึ้นมาแต่เราต้องได้ชีวิตไทยของพวกนี้เราสามารถเชื่อราคาไปข้อมูลได้มันง่ายกว่าใช่เดินที่เราหมุนคนแค่นั้น ตั้งมือตั้งตั้งเลยแล้วเป็นหนึ่งต้องรอนานจะให้เวลาหน่อย
ยังไงอ่ะ
เขาเปิดเลยที่เราทำหรือทำที่ว่า
เป็นการติดแล้ว
ใช่ครับเชิญได้ดูที่ใส่
ได้ก็คือเรียนเลย
เลย
Yes, to make sure it's everything done on this time. Their focus is on some of them. I don't think you went for and before they there's a bet on that you went on.
ใช้สมองเยอะเลยก็เลยมันก็เหมือนกันติดตั้งหลักเราหลังจากสวิตช์เห็นไหมก็ยังไม่รู้เลยติดเขายังไม่ได้ใช้ตรงนี้เขาก็หลังตรงนี้แค่เดือนเดียวมั้ง
Basically,
พอเป็นตอนคนที่เราไม่ได้เรียนเลยไม่ได้เรียนเลยเพราะว่าเขามาติดตั้งอย่างเดียวไม่อยู่ในสต็อกชุดไม่ทำเป็นฟันมีปัญหาแล้วเสียสายตั้นนั่นเลยที่ประเด็นที่เราไม่รู้เลยว่าตกลงถ้าเกิดว่ามันบอกว่ามีปัญหาปุ๊บมันต้องมีคนจับเราเข้ามาต้องพอร์ตเราก็ได้นี่พอมีปัญหาตัวเครียดมันไม่มาเลยผมว่าต้องโตไงมีสองไม่มีเหลือคนเดียวแล้วตอนนี้แล้วลูกค้ารอไม่
ไม่มีเวลาเลย
I separate the different methods. So this
มันก็
method
น่าสงสัยตรงที่น้ำมันไอ้น้ำมันพืชประทุมเนี่ยมันไม่ต้องซัพพอร์ตแสดงว่าเครื่องมันไม่มีหนักเลยคือเราใช้ที่แล้ว
yeah, yeah.
แล้วมันติดกับไฟสายตัวติด
เป็นเด็กเหมือนกันมีตัวตัวก็มีเข้ามาอีก
The first one is like doing separation from the edges.
ถ้าแสดงแต่การก็ได้
The leading talks will collect bias.
ทุกอย่างเราส่งไปให้ทีมมันอื่นรู้แล้วแล้วทีมมันไม่แก้ไขมันก็จบท้ายก็พูดอย่างนี้แต่ตอนนี้เราไปพูดอย่างนี้ลูกค้าก็บอกว่าเราไปลองดูว่าถ้าเกิดใช้อะไรครับมันมีปัญหากับเราไหม
But you are using this
เรา
method.
ก็ไม่ได้อะไร
This that you when you want to collect sample
ที่ว่ามันเป็น
when you want
มันเรื่องแรกหนึ่ง
separated
คิดว่าราคาแทนถูกกว่าของขนาดที่
like moisture
น้อยกว่าเรา
or
อย่างนี้ดีเขา
putting more or
ไม่ใช่ EDTA ตัวแท็บอะตัวโอเวนแท็บในปั๊มอะในบริษัทที่ให้กำลังใจเช็ควาล์วเขาก็มีของเขาเป็นตัวน้องเวส
something else but
เหมือนไม่รู้เกิดใหม่ที่นี่บอกว่าสมัยก่อนเป็นโอเคกดเข้าไป
ไม่รู้ไม่เคยเราก็ยัง
อัดเท่าไหร่ก็ได้ไปเรื่อย
I think they should inject
ใหญ่
เราก็เหมือนว่าแล้วถ้าเกิดเราเลือกมันเลือกได้อะมันจะเลือกตัวแต่ละคนติดตั้งไงตัวก็เหมือนว่ามันก็ไม่กล้า
สบายใจแล้วสบายใจแต่ติด
ได้นะไอ้พวกศพคนนี้ก็มีอะไรได้มันต้องมีแข่ง
แต่เขาบอกว่าเวลาไปเป็นที่คุณเขาก็50-50เขาบอกว่ามีทีมมันตื่นเต้นมี
and if
อาทิตย์ละแค่หนึ่ง
คนจะ
ระยะ
if you don't get the what is it then you use that one and inject just higher
เชื่
taxation
อถือได้บอก
would be more or less the same but when you want to trace
แต่เราก็ต้องขายของเรา
the contamination in the system you want to pull out the fluid
แบบอย่าง
you can use that method this one always uses a syringe
มาทีละต้องหัวปลาต้องตีฟันชุดนี้ต้องเอาไปล้างหัวปลาแบบเต็มแต่เต็มเพราะมันต้องมีปัญหาแต่ของเรามีปัญหาคืออีกก็ต้องตอบดีแต่เขาไม่ได้เป็นแค่เป็นความมันยังไม่ได้แบบมีปัญหาเขาก็เบียดที่แล้วเราที่เห็นเขาก็ถือว่าเป็นเรื่องนี้แต่สรุปก็คือมันเป็นปัญหาจากต้องเป็นความร้อนหรืออะไร
ก็คือมันจะเป็นปัญหาจากไดโครบิเทนเพราะว่าแต่ว่ามันเป็นทุกลายเพราะว่าลายที่เรามีปัญหาคือลายของตลอดซึ่งมันไม่ได้ใช้ตัวเว้นเป็นไดโครบิเทนเลยอ่ะใช่คือปั๊มที่เป็นปั๊มเล็กเซ็ตอะไรเป็นไอโตเพน
sure why it is in this folder this is only for SAT yeah all these 2 or 3 that
ก็คือมันร้อนแล้วก็ทำให้มันคลายตัวได้
but normally you don't just have so much with expensive nylon to be about everybody
ก็จริงๆมันรู้เพราะเด็กมันเรียนแต่เราเป็นปัญหาอยู่ไม่เกี่ยวกับเด็กคนเรียนเลยเราก็ต้องถามเขาว่าจะให้แก้ยังไง
But I'm so sorry. Will you go and explain one by one the methods? What is it about?
not today but yes it will
All right.
future question
Just want to ask.
ไม่มีอะไรไม่ก่อนเอาไปเลยขยะคือบอกจะโดนดี
Stop. But
อ๋อหรือได้ละก็อีกสิ่งเดียวยาสติ
ไปคิวแลบโซลูชันเนี่ย
sounded it เป็นหลักพี่หนุ่มพี่ใครอะไรนะข้าวปนุนใครดูแล
ไม่ได้ซื้อกับเรา
อยากรู้
ทำไมซื้อเองเพราะซื้อตรงอย่างนี้เลยไม่ได้ผ่านใครซื้อดีพอร์ตมาจากต่างประเทศเลย
แต่ไม่ดูแลเลยนะครับ
เขาก็ดูแล
เขาดูแล
ไม่ขายค่ะ
ไม่ใช่ก็คือมันซื้อมาจากซื้อเป็นบ้าเลย
อาจจะไม่เกี่ยว
ทีนั้นไม่เกี่ยว
ที่จะไม่ค่ะต้องถือว่าถูกกว่าเรา
ก็เหมือนกัน
ที่การเห็นว่าเขาบอกว่าอะไรที่มีปัญหาแบบสังเกต
เขาเลือกที่จะไม่เอาเรา
shall we
ก็
go
เหมือน
back
กัน
to the
ที่
room?
DS เนี่ยมาถามเรา
Let's go back to the room.
ไม่ได้ดูหรือว่าจะขายยังไงเขาก็บอกผักไปนี่มีแล้วมีเทอร์โมมีอะไรเขาก็พูดได้ว่าแต่ว่าอาทิตย์แล้วมันบอกเขายังให้ดับไปอะไรเชื่อไม่ให้มันให้ติดต่อที่
Are you going to hang up this or? Yeah. You stop everything now?
I think we have learned again a lot for one day. I'm pretty sure that it might be even too much for a single day. But for tomorrow, we have then hopefully our injections. We have done now first our automated workflow. That's so from, let's say, from the sample preparation point of view and also from the daily use case of the point of view. It doesn't get more complex than this. That's all what a customer typically needs to do. So I hope at least when you forget all your confusion, you see that it's, in the end, it's not that complicated to have a running system at least. Okay? Within the injections, we have talked about what is where on the system. Of course, we will look into this much more deeply. And only to summarize why we did all that is we started with 20 milligrams, what we could inject without saponification. Even with saponification, because of the limited size of the sample loop, we could only inject up to 67. That would be the injection of 100 microliters. Therefore, and also to comply with the limits and to get up to 200 milligram of injection, we switched the sample loop, made everything bigger, so bigger sample loop, bigger syringe, bigger injection, so that we got up to 400 microliters. This is now only the MOSH chromatogram. No, it's the MOA chromatogram. No, it's the MOSH chromatogram. From here to here, only by an increase of the amount we are injecting into the instrument. That's the only trick which is done to increase the performance or the sensitivity of the instrument. There's no trick. We cannot improve sensitivity by a better FID or whatever. Honestly, all FIDs on the market for all vendors have essentially the same sensitivity. Be it from Thermo, Agilent, Shimadzu, whoever, an FID is burning carbon inside. So what do you expect from it? In the end, it all comes down to the sample amount that's injected into the instrument. And with that, I think we have finally gone through the first introduction presentation. Yeah. Only to summarize, we have learned about a coupling of LC and GC, why we are doing it in this way, also in combination with the FID. Why we need this automated workflow and why we can't just inject a simple sample onto the instrument, although the original method, that was the plan for the method. But as always in life, plans do not work out that easily. So we have now saponification included and solvent evaporation and all that kind of stuff that makes the sample prep, of course, more complex, but with the benefit of a higher sensitivity. And even though you still don't know why it is working this way, but we have the aluminum oxide cleanup for the removal of the peaks in the MOSH chromatogram and epoxidation in the same idea for the MOA chromatogram. That's all for now. What the idea was behind this introduction. So everything we have learned besides that will most likely be part of another presentation later on. So whatever questions you have or whatever questions I might have answered up till now, there's a high chance that we will talk about this again. Okay?
Marco, just to ask the previous slide, how do you know, is there any indication to say that this is a MOSH chromatogram?
You can see it by the internal standards. So first of all, this is here cholestain, one of the internal standards which we are giving that. And from the peak shape, you will see when you know a few chromatograms, Perylene is giving you another peak shape than cholestain. Then, of course, you're seeing it from the start of the solvent band. It's starting here at 5 minutes. It's because we have done aluminum oxide cleanup. When we are doing aluminum oxide cleanup, it's shifted to higher retention times, around 5 minutes. And when I would zoom out, you would also see that from the internal standards here at the beginning of the chromatogram, that you do not have 4 peaks so it looks like that for the MOA, but it is only 3 peaks in the beginning. So you can easily see on all chromatograms if they are MOSH or if they are MOA. Or let's say you will learn how to see it.
Yes.
Okay.
Yes, before we end the day, do take note, tomorrow is fire drill, so I guess maybe you